Alright, so geometric sequences. Yesterday we did arithmetic where you added each time. Geometric is just where you multiply each time. So, example might be if I take 2 and I multiply by 2 each time. So 2, 4, 8, 16, and keep going like that. So what you multiply by each time, that's called your common ratio. You can always get your common ratio by taking 2 consecutive terms, which they always use R to represent. I should give you that. You can always take 2 consecutive terms and divide them. So that's how you get R. So that's a geometric sequence. R can never equal 0 because that would just be ridiculous. Usually we don't have R equal to 1 either because, again, that would be, yeah, but technically it could be because that's not in the definition. Trying to think if there's anything else in the definition. I don't think so. I think that's all that's really. Yeah, that's it for definition. I don't know why I left so much space. Formula. That's your formula. We could make a recursive formula. Recursive formula, again, is not helpful, just like with our arithmetic sequence. The recursive formula wasn't really helpful, but we could make it. We just take the prior term times R. Because that's pretty much your definition of a geometric sequence. You take the term, to get to the next term, you take it times your whatever number you're multiplying by each time. Alright, but again, just like with the other one, you guys need to memorize your formulas for this. So that would be the formula that you guys need to know. All right, you good with that page? Oh, there. All right, so let's go through some examples. So what we've done so far. So again, anytime they ask for the nth term, all you're really doing is you're finding the formula. So all I'm doing is plugging numbers into that. So A1 is my first term. So what's my first term? 2. Okay, R is my common ratio. So what's my common ratio? What am I multiplying by each time? Close. Not just 1/2. Negative 1/2. Because it's switching signs each time. And then n minus 1. Again, If you ever have problems finding this, you just have to take two terms and divide them. So if I needed to find r, I could just take -1 divided by 2. So I could just take my second term divided by that first term. And that could give me the r.
Is that one
Yep. Yeah. Any geometric one. Okay, so then the rest of them are, again, just more of the same thing. They're just giving you a little bit harder ones. So I want to find the 20th term is 64, and the common ratio is 1.5. So what's the nth term? What? This. So finding the nth term. Yep, that's all it wants you to do is find the equation. Anytime it asks for the nth term, that's all you're finding is the equation.
What would it say for a number?
It would ask you to find like the 18th term, so like on number 3. Okay, so from this, finding the nth term, they tell me what the common ratio is, which is 1.5. But I don't know what the first term is, so I have to figure that out. So that's why they gave me the other information. They told me the 20th term is 64. So I can take this and plug it into that. So 64 equals A1 times 1.5 to the 20 minus 1. I should really get a calculator and leave over here.
Radius.
Okay. A whole bunch of them out today. So 1.5 to the 19th is this god-awful number. So 64 divided by that god-awful number. I'm just going to round off at a couple places. This is what you get whenever I make up a problem. So then we get that. I'm sure the ones the book has, you'll come up with nice, pretty numbers. Okay, then if you're asked to find the 18th term of the sequence, again, in order to find the 18th term, you could take, this is multiplying 3 each time. So you could take and multiply 3 18 times, or you could just find the formula and then plug 18 into the formula. So the formula would be, take the first term, each time I'm multiplying by 3, and then just plug 18 into it. So the 18th term would be that. So 2 times 3 to the 18th, or 17th. So this huge number. Which happens with geometric terms. Geometric terms grow very quickly because they're exponential. Does that help?
Is that a really big number, or
Yeah, that's a really big number. If I put the commas in there. 258,280,326. And that's by just starting at 2 and multiplying by 3 18 times. Not many. Okay, next type. Okay, so if the fourth term is 125 and the 10th term is 125 over 64, what is the 14th term? So this is kind of like the one we did yesterday with the arithmetic sequence. So the 10th term would be equal to the fourth term times the ratio how many times? So if I started with the fourth term, how many times would I have to multiply by my ratio to get to the 10th term? 6 times. Every time I multiply by that number, I would keep it would raise exponentially. So now what I need to do is figure this out. Since I know the 10th and the 4th term, I can figure out that ratio. So the 10th term is 125 over 64. The 4th term is 125. So it gives me 1 over 64 equals r to the 6th. The 6th root of this is going to be 1/2. Okay, so now what?
create your early?
Yeah, I'd have to find A1. So AN equals A1 times 1/2 n minus 1. Now I could use either one of these to figure out what A1 was. Do 4? Okay. So the fourth term is 125 times A1 times 1/2 to the 4 minus 1 would be 3. So I'd have 125 equals A1 times 1/8. So then I'd multiply both sides by 8. So that give me 1,000 equals A1. So then all this work together tells me that my formula is this. Now that I have my formula, I can plug 14 into it. So 1,000 times 1/2 to the 13th power. I don't want it to look like that. How do I change that to a fraction? Okay, let's do it this way. One half, or here, let's 2 to the 13th, now 2 to the 13th power is 8192. Okay. There we go.
Do you want us to have it in fraction form?
I don't care. That was more me being crazy than anything. Yeah.
Okay, when I looked at this, I got half of that. And so did
Did I mess up?
I got half the too.
Dang it.
so it was equal 125
So I messed up. All right.
Yeah.
Okay, there you go. Oh, that would be right. Yeah. Okay, I was off by 1. I was. Okay. All right, now. So series is where we want to add them all up. So we have a sequence, we want to add them all up. So, we find, like on example 5, we find 15 of these terms and we want to add them all up. That's a lot of work. So we have formulas, nice little formulas to calculate this for us. I don't want, sorry. Okay, so there's your formula. I wrote a whole bunch of stuff there, but basically this right here. I wanted you to see what it would look like. So notice this part inside here, that's your geometric series. So that's how you would tell that you would need to use this formula on a regular problem, because you would see your geometric formula inside of the summation sign. So if I wanted to find this, I would take, okay, so my first term is just going to be the number in front, correct? So I would take 4 times 1 minus negative 2 to the 15th divided by 1 minus negative 2. Alright, so negative 2 to the 15th. So I have 1. Okay, that's going to end up being negative, so it'll end up being 1 plus. Divided by 3. And then take that times 4. Which is a lot easier than figuring out each of those terms and adding them together. So again, this is going to be an equation that I'm going to ask you guys to memorize.
How many do you want us to memorize?
All of them.
Okay, then that's enjoyable.
24 and a half. I know you had the equations for writing your arithmetic sequences. You had the equation for finding the partial sum for an arithmetic sequence. You have the formula for writing a geometric sequence. You have formula for finding a partial sum. And then with geometric sequences, we also will have a formula for finding an infinite geometric series. Now, there is a problem with the formula in your book. I should make you guys figure it out. Why? You're going to trust me to tell you? They start your formula at 0, but then they give you a 1. Well, if you start at A0, where's A0? There, yeah. So they messed it up a little bit. So I'm going to give it to you a little bit differently. It really doesn't matter. I can show you the difference. So your formula either needs to look like this, or it needs to look like this. Oops, that's supposed to be an R. And can you tell the difference between the two? They really come down to be the same thing. Basically, on your first term, you want your power to be 0 so R doesn't show up. Wherever you're going all the way out to infinity, it doesn't really matter whether you start at 1 or 0, as long as your first term doesn't have R in it.
What do you mean by the first one doesn't have R?
Well, whenever I do my first one here, I end up with 1 minus 1, so R0, R disappears, right? Because it becomes 1. Well, here, whenever I put 0 in here, that's R0, so it becomes 1. So it disappears.
So then we don't want that?
Yeah, your first term, you don't want R in it. Okay, so in this case, your formula is A1 over 1 minus R. In this case, your formula would be A0 over 1 minus R. So see, again, it doesn't matter. It's just your book took the two formulas and mixed them together. All right, so now the other part of this is in order for this to work, and again, r cannot be equal to 0. But r has to be less than 1. It has to be in between 1 and -1. There's a thing called convergent and divergent, and we're not talking about the movies. Those movies sucked. The books sucked too. But convergent means that as you add these things together, it gets closer and closer to a single number. Divergent means that as you keep adding these together, it pretty much just blows up. It keeps getting bigger and bigger and bigger and bigger and bigger forever. It never gets closer to anything. If it's bigger than equal to or bigger than 1, it'll just keep getting bigger forever. You'll never get closer to anything. If it's smaller than 1, it'll converge to a single number, in which this formula will work, and it will tell you what that single number is. So, like in this case, this is going to be equal to 2 divided by 1 minus 1/2. So that's 2 divided by 1/2. So this converges to 4. So if you took all those terms, which you can never write out all those terms, but if you could add all those terms together, eventually it would equal 4. So the more terms you write out and you add together, the closer and closer it gets to 4. All right, so all right, so that was your last notes for me ever.
Yes.
You can cry now.